All right, so welcome to our presentation tonight. We are the science department, and we're going to be kind of talking about our new curriculum that we are adopting or kind of piloting here at Knoxville High School. My name is Chris Peaton. I teach physical science and advanced physical science to all of the ninth graders in the high school.
I'm Mr. Moats, Nicholas Moats. I'm teaching 11th grade chemistry.
Ryan Richardson, I teach biology for sophomores.
Mr. Gibbons, and I teach physical science and biology. So what the new curriculum is called is Open Sci Ed, and it's different from what students may have kind of experienced before. So the classes that your student may interact with this in will be the core classes, so physical science, biology, and chemistry. And so a big kind of part of this is it really gets the student to engage in investigations, in real world kind of relevant scenarios and problems. And a big part of it is looking from the student perspective. So how do they view it? What do they see? Not necessarily from kind of the more traditional teacher side part of it, kind of that expert. So can the student actually, how are they going to experience, how would they investigate this phenomenon or this kind of issue or problem that is happening? And so the goal is can they develop, or our goal is to help the student develop their, use of science, these principles or ideas, engineering practices. So how can they develop certain things? And one of the ideas is, can we build kind of a deeper understanding around key concepts and ideas that were identified a few years ago by, that were passed on from what was called NGSS, so Next Generation Science Standards. And so can we help students develop these and kind of build this connection in science? And so what you're seeing here is kind of this different way of teaching, or what the student goes through. And so students in any of our classes, the first thing they do with each one of these units is they get this anchoring phenomenon, this question, this issue or problem. So in like physical science, with Mr. Peaton and myself, we looked at the beginning of this unit, the blackouts that happened in Texas about a year and a half ago when there was that hard frost. So what happened? Why did they occur? And then the students start creating questions that just are around that. They may not have known very much that happened, but why did it occur? And then throughout the rest of this unit, the students are investigating and putting together their questions and figuring out, okay, what could have caused this? How could they apply, what did they learn, or how could they apply what they're learning to help this not happen again with what we did in this unit specifically?
All right, so next step here, kind of for this presentation, each of us that have the course sections are going to kind of walk you through how did this first unit go, what did it look like, what was your student kind of doing, and give you a little thought into the future as well. So I'm going to start us off here with physical science. So again, this is for the ninth graders at the high school. Our first unit was, how can we design more reliable energy systems? So Open Sci Ed always starts the unit out with a overarching driving question. That's kind of our anchoring thing. And as Sean mentioned, our phenomena that we used was the unreliable energy system that we saw in Texas last year during the winter storm. So a common word that Sean used there was questions. It's all about getting the students to foster questions. And you can see over on the right side of the screen there, we call that our driving question board. So the students made a model of what energy looks like in our community here at Knoxville. You can even see the big power area in there. That was the name that the students in section 4B gave it. That's representing the gray power station kind of transformer substation across from Mr. C's. So we're using things that are relative to our everyday life, something that these students see maybe every day on their way to school, and we're asking questions about it. What is that? How does it work? How does it help us? Is it reliable? So then we move on and we start using the resources that we have, and Open Sci Ed is really awesome because it allows us to have access to some pretty great resources, even everyday simple things. You can see in that top middle picture there, just a power strip that I've deconstructed for the students, stripped some of the wires, and we took a power strip, we figured out how it worked. Through that, we figure out kind of how does a circuit work, what's electricity look like, and how do those things all fit together. And then we ended up making a town's power grid out of just some alligator clips, some wire, and an extension cord or a power strip. So we're using, again, everyday things to model things that these students are familiar with, and we're learning those key science concepts throughout all of this. And then there at the bottom of that middle picture, you can kind of see where we wrapped it up. Your student just took an assessment from me earlier this week using this exact picture, and now we're talking about how does energy transfer. And again, it's building all off of that. Can we make a more reliable system? Well, could Texas have used waves instead? That's the question. And your students kind of walked us through how does energy move through this system, working with the buoy and the magnets. We've learned in this unit how generators work with the magnets moving, and they put all that together in a nice little unit assessment here. We call it a transfer task in Open Sci Ed. They'll hear that word a lot. And then we're ready to move on to our next unit. And our next unit in physical science here is going to be talking about the Earth and the layers within the Earth, and kind of how density plays a big role there for us.
In biology, we started working with the Serengeti National Park in Africa as our phenomenon, where we see a wide variety of different species interacting with each other. And one of the nice things about Open Sci Ed is they pay a lot of attention to equity, meaning they don't want students to come into the classroom with a wide variety of different experiences where some know more and others know less. So they put us into an ecosystem from Africa where we all know almost nothing at the beginning, and therefore we all have the same learning experiences. We all have that same base level knowledge, and therefore we can all communicate well with each other. And we don't have one group of people saying, well, because I'm a farm kid, I know more, or because I have a family member in this industry, I know more. We all have that same base level of knowledge. We've used a lot of different skills in order to learn about the Serengeti, to include model building that you see on the screen there. And there's a tool called Sage Modeler that we've used many times, where students use icons, like on the screen you see a zebra, cattle, buffalo, wildebeest, and we link those components and ecosystems together, showing relationships between those components. Some of the red arrows there show that the grass is eaten by the buffalo, the cattle, the zebra, etc., and therefore energy is transferred from the grass to all those herbivores. We've also been looking at a lot of real-world data in the graphs there to show that the buffalo population and the wildebeest population goes up, goes down in response to a wide variety of different circumstances in the Serengeti National Park. Some of those circumstances have been very predictable for students, the interaction with predators. Others have been completely unpredictable. We go through investigative routines and it's not that one. We go through a second investigative routine, it's not that reason. And finally the students do some reading and realize, oh, there was this disease that kept populations artificially low, and when we vaccinated cattle, suddenly the populations of wild animals were able to increase greatly as well. So there's a lot of tool use, a lot of data analysis, and like everybody else has talked about, a lot of questioning. So students are involved in lots and lots of discussions. It's very different from our many years ago, here's the textbook topic, I teach it, you learn it, we practice it, we apply it, and that's kind of it. The next unit that we'll get into is all about trees, and can trees, or the planting of trees, impact climate change? I've not been trained on that one yet. We're interested to go to training and see what that one's all about next.
So I'm Mr. Moats, as we said before. So in chemistry, for all of the 11th graders this year, we were looking at how can we slow the flow of energy on Earth to protect vulnerable coastal communities. So with that, we were looking at how does glacial ice and the melting of glacial ice affect different places on the Earth. To get into that, we started looking at, okay, where is this ice? How does ice melt? Where is the ice melting? We looked at how does the energy transfer between objects of different states. And we also looked at what geoengineering solutions there are in order to slow this type of energy. We've done a lot of looking at more specifically the what's happening in the molecular level or what's happening between atoms in these places and between different things of different states. So we just wrapped that up a couple weeks ago. With Open Sci Ed, this year we currently only, so chemistry and physical science, we're only teaching 2 units from Open Sci Ed. So we have one that we just finished up, and then we'll have a second one later on in the spring semester. Biology, they have 3 throughout the year. So we don't currently have the full year's worth of material. We're just piloting these ones, sending results back to the Open Sci Ed people on what things went well and what things maybe need changed for the rest of people to go to do this. As we go into next year, we'll have a full year's worth for all 3 courses. So moving on for second semester, we've got a filler unit. So before we start our next Open Sci Ed one, where we're going to be looking at how should we search for life beyond Earth. And with that, we're looking into like what molecules are and which ones are important for life. We're going to look into water, electrolytes, ionic and covalent compounds, and kind of use our search for life outside of Earth as the lens where we learn about these different chemistry concepts. And then second semester, when we get into the second Open Sci Ed unit, we'll be looking at shellfish and more specifically like acid-base chemistry and how that applies to our oceans.
So just to kind of wrap up, when we look at this, kind of as Mr. Moat said, biology is going to have 3 of these open sites, so kind of this different type of kind of this learning, this more in depth. This year, chemistry has 2 and physical science has 2. With biology, first semester will have 1 of these units, second semester will have 2. Chemistry is 1 and 1, physical science is 1 and 1. And then going into next year, so the 22-23 school year, biology will add in 2 more, so for a total of 5 for the whole year. Chemistry will have 5, so again, going over the whole entire year, and then physical science will actually have 6 for their whole year, as we get trained and kind of have and adopt kind of that whole curriculum to take a look at it with that. So.
All right, so that wraps up kind of what we have, our little spiel here over Open Sci Ed. If you have any questions, now would be the time to throw them in the chat. There might be some already in there. Currently, there aren't any, so we'll leave that open maybe just probably a minute here or so. And if we don't see any pop up, we'll wrap this up today. So.
See, if there's nothing else to talk about and some time to burn, we could always plug a couple of clubs that we sponsor. I tend to sponsor Science Club. Tomorrow we actually have students going up to Iowa State University, getting an introduction to the physics and microbiology departments. We'll also take a trip tomorrow evening to Drake University to actually hear a topic that I should have talked with you more about. The topic is titled, Are Earthlings Alone? Which would fit right in with your current unit. And of course, you sponsor the esports club.
Yep, so esports club sponsor. This is our second year. We've got 1 team currently playing Overwatch in nationwide tournaments. And then we've got a few large group events going on at the school throughout the semester, throughout the year. So.
All right, well, doesn't look like we have any questions or concerns or anything in the chat, so we're gonna wrap this up here. Thank you very much for joining us tonight. We really do appreciate it.
Goodbye.